Action.
Is this for yearbook or is this the seniors doing it?
Yearbook.
Yearbook.
I mean, seniors are doing it.
I know, I was like, is this something I'm supposed to be doing? But
We were talking about the
It's a good
subjective. What?
oh, good.
Alternatives?
Alternative facts?
No, the things we just did. Superlatives. That's what we just did, George.
Alternatives. Close it.
Oh, we're recording.
Now we are.
This class.
Now we are. That would be appropriate. All right, so.
Yeah, right. Go.
You're like voiceover person.
Good, I've heard that a lot.
Oh, okay.
So when I become like Peyton Manning, oh wait, I already am. Did I tell you guys I know Peyton Manning?
Yes.
I basically know him.
You told us.
Yeah, I know Mr. Richmond, who knows Mr. Marshall, who played football with John Elway, who knows Peyton Manning. So basically, I'm best friends with Peyton Manning.
Go back to
See, Deb? Deb gets it. Deb gets it.
No, I get it. I just don't like it.
It works.
Every time.
It works, and I'm best friends with
Dun,
him.
dun, dun.
I don't think.
It's that whole idea of like you're separated, what is it, 7 degrees?
Yeah, it's the degrees, yeah.
Yeah.
So it's me to Richmond, Richmond to Marshall, Marshall to Elway, Elway to Peyton Manning. That's 4 guys.
You should like make a graph.
If you,
Even then.
they say if you skip 6 person, you know everybody in the word.
Yeah, but that's crazy. I don't.
There's a game for like a few good men because there's so many actors in it. Like you have to
Bacon-
go 6
Bacon
actors, and the last one you start at one movie and you end at a few good men. And it's really hard.
No, but
I'm
yeah, that's
lost.
the bacon.
You need to explain that one. I don't know that one.
Or the Wiki Walk. You ever done that?
We used to play that
We used to play it all the
the
time.
time.
He's not liking it. Never mind.
Okay,
He never
we
did.
should do math today.
Let
we
me
can
know
do it.
after
Amanda.
class what all these fun things are. Okay, 9-6. Before we do 9-6 question, you guys are supposed to finish 9-5 yesterday. Any questions?
No.
No, we're good. I mean, we had a couple.
No,
We're carrying one over, and you guys kept working. Hey, Deb's looking. Cool. All right. Ratio root test. Oh my goodness, it's the last section. When's our test again? One more time, just because I don't trust you guys to remember.
Monday?
Wait,
test?
tomorrow's the forever one though, right?
No, Monday.
Monday's the for never.
Monday is the for never.
You're
There you go.
welcome.
Thank you,
You're welcome.
Amanda. I
The
appreciate
forever
it so
never.
much.
Is on Monday,
One
and our last homework is due on Monday, which is this one, section 9-6, and our chapter 9 AP is due Monday.
What?
Guys, there are APs on,
But I have
on
questions.
Tuesday
I know
midnight.
it's due Monday. Today is Thursday.
Ooh, May 9th, that's an extended one.
And Monday, if I remember. No, I say tomorrow. Tomorrow or Monday we might have extra time to go over extra questions. And then Tuesday is review. Oh yeah, because Monday is just like a turn-in day, so we'll go over any remaining questions on chapter 9 AP, but you should have fully attempted it. And then Tuesday review, Wednesday test. Dun dun dun.
Dun, dun. Are we not gonna get a handout for this section?
I totally just forgot about it. Oh well. Section 9.6. What do you guys have?
I.
There's not really that much writing, so it's just the test. We're good.
Cool.
It's the writing in like 6-7 examples. These tests are awesome for very specific cases, but very specific cases that are very hard to do any other way, like factorials. Like factorials. Because limit comparison test, we can compare factorial to somebody else, but if we compare a factorial to a factorial, we still have to figure out the convergence divergence of a factorial, and that's just rough. But the ratio test says, you know what? There's a better way to deal with factorials, and the root test says there's a better way to deal with roots. There you go. Once again, you guys see the condition of positive terms. Uh-oh. So if they're negative, we have to figure out something else, basically. But we're kind of used to that one. I think, don't we usually make it blue? I feel like we make the conditions blue. Oh, it's still red.
I think it's red. Yeah.
Oh, it's red.
No, it's blue. You're right.
Oh.
Yeah, tell me twice.
Okay. The ratio test says, oh nice, hey, they're limits. We like limits. We like limits that tell us things as opposed to limits that tell us nothing. This is going to be, not forever, endeavor. 20, is it 23 or 24?
Oh,
22.
Oh. I thought we were further.
I don't know if that's sad or happy.
A little bit of both.
It's just a fact. number 22. Number 22. So, it's a series that has only positive terms. The ratio test says the n plus first term over the nth term. Oh, so like the factorial thingy over a factorial thingy, kind of like we saw yesterday. Taking the limit, and we're assuming, well, we're saying the answer is L. Root test, the limit as n goes to infinity of a sub n to the 1 over n, which of course we can make a root into a fractional power. If that equals L, we have the 3 bullet points for our conclusions. L is less than 1, the series converges. L is greater than 1, the series diverges. L is equal to 1, we know nothing. Oh, man. So the one that we don't like in this one is L equals to 1. So we don't like L equals 1. But we do like L less than 1 or L greater than 1. We do like L less than 1 or L greater than 1.
What does the ratio test tell us?
The ratio and root tests work the same way in the sense that we take the limit of whatever they show, it equals an L, and then take those L's to the bullet points below. Does that make sense?
Yeah.
So what if the limit is 0? Less than 1. Good. Converges. What? But be careful, it has to be within the ratio and root test, right? You're not just taking the limit of the nth term. That's where the limit equaling 0 starts to get really confusing. The nth term test, the divergence test, you take the limit of any sequence inside a series. If it equals 0, we know nothing. But if it's an alternating, we can know conditionally convergent as long as a sub n plus 1 is less than a sub n. And for ratio and root test, if the limit equals 0, then the series converges. But we have to be plugging into these formulas for each of the ones above, right? If we're not plugging into those formulas and we get the limit equals 0, once again, we know nothing. So just be careful. Now let's put this guy in parentheses. I don't want to give him as much credit as the other two. The ratio test. The ratio test is a really good one for factorials or nth powers, and the root test is a really good one for nth powers as well. So the ratio test is the one that's most useful for factorials, can be used for nth powers, and the root test is the one that is useful for nth powers for obvious reasons. You're taking a root, right? So, what's below? So helpful with factorials or nth powers. Question, what category would the limit equaling infinity go under?
Greater than 1?
Greater than 1.
Negative infinity.
Less than 1. Got it. Okay, we ready?
Better than number.
We good? Ready, set, and let's play. Could we do a limit comparison test of 1 over n squared and the limit is 0, and so therefore since convergent, ours converges? Yes. But what else could we now do?
Ratio test.
Wait a minute, the terms all have to be positive. What's 1 factorial?
Wow.
Okay, that's lame. What is 2 factorial?
2.
What is 3 factorial?
6.
What is 4 factorial?
24.
What is 5 factorial?
S-
What is 6 factorial?
How do you know it? It's D?
Because you multiply by,
5.
oh wait, where am I going?
Wait,
My bad.
5 factorial is 100 plus 120.
6 factorial is 7. So, remember, 2 is 2 times 1, and then 3 would be 3 times 2 times 1, or 3 times the previous. 4 would be 4 times 3 times 2 times 1, or 4 times the previous. You see it? Please, Steph, can I have some more?
Oliver Twist, right?
Such a sad. Don't stay away. Okay. Find ratio test. Come on. Since we haven't even done any work yet. That's all right. What am I about to do? Exactly. Since the limit as n goes to infinity of what goes on top?
1.
Nope.
Oh.
Nope.
1 over n factorial.
Nope.
1 over n plus 1 factorial.
There.
Ah.
I was so confused.
It's the n plus first term, right? Over the nth term. Double check. N plus first term over the nth term, which is the same thing as
It's going to be n factorial over n plus 1 factorial.
to be reciprocal everything, which is the same thing as, use our skills from yesterday,
N plus 1 on the bottom.
y n plus 1, because n plus 1 factorial is n plus 1 times n factorial. They cancel, right?
Can't we just hit the bottom stronger?
I think
I agree with my sorry.
you could say that statement, but I think my math is a nice clear cut, you know what I mean? And 0 is less than 1, right? The series does what?
Convergence.
Dun, 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 dun. Hey, he's nice. So in last section, you were given a couple factorial, or maybe just one factorial ones, just to see what you could do without this test. But now we say, yeah, forget that. For any factorials, just do the ratio test, for the most part.
On like the test that we're gonna get on our test and on the AP, is direct comparison and limit comparison like gonna come up often or like no more than one or two problems?
Less than 5 for sure.
And they're
Probably
not
one or two.
ridiculously hard like the ones we've had.
Not necessarily. You would not be forced to do the direct comparison test on a long answer. Let's just put it that way. So if it's in a multiple choice, you can use whatever method is legal. So you can use limit instead of direct, you could use ratio instead of limit, depending on the problem. Okay, next example. Almost. If it was 1 over 2 to the n. Ugh, do we want to integrate that? No way, Jose. Do we want to do limit comparison? Not really. Because if we do 1 over 2 to the n, that's convergent, but then the limit is infinity, that's not good. Direct comparison, ew.
Okay, the ratio test.
Yeah, well, maybe.
We do root tests since there's an nth root.
We could actually do either one. Because it's an nth root, or there is an n power, that's one way of saying it. So let's go ahead and do ratio test since we were just doing that, and then we'll see how the root test works. So let's just put this guy down the middle and say, let's do him both ways. All right, so by the ratio test. Zoom in. Giving too much time. N plus first over n.
Oh, there we go.
So plug in n plus 1.
Yeah.
You got it?
Yeah, I got it. Just took me a little bit.
Can't we just, instead of dividing, do multiply by the reciprocal?
Yeah.
Yeah.
Right.
And then we can subtract.
Can we just keep a 2 to the 1? And the 2 to the n?
Yeah, because we can make this guy
Yeah.
2 times 2 to the n. That's a good idea, right? So we end up with n plus 1 all over 2n, which equals 1/2, which is less than 1. How's that look? Oh, if it keeps writing. There it is.
Converges.
Series converges.
Will it ever be? What if like? Never mind, it's probably not.
What's impossible?
Or to converge with the root test and then
No.
with the ratio test.
Good question, though, because that would be really scary if that was true.
What?
If one test seemed to show one conclusion, whereas the other one test showed another conclusion.
Oh.
That'd be sad times. By the root test.
with the ratio?
I'm writing that no, remember we're
Oh.
trying an
Oh.
alternate method. Why keep writing so big? Okay, what are we taking? What limit when we're doing the root test?
The limit of
He said then to the 1 over n.
to the 1 over n. Which we could
I guess you could say it's like
we multiply powers with this being
it would be 0. It would be 1/2.
Okay, remember, n to the 1 over n. Number, plug in 0. Or no, plug in infinity, and 1 over infinity it converges to 0. Anything to 0 is 1, and we can only use that trick because we learned the special converging sequences. It's true, right? So we can say that's the same thing as.
Is it good that we're able to like recognize what tests go with what on a problem just by first looking at it?
That's the goal. That is definitely the goal. Did it match? Yes. Is that a good thing? For sure. Once again, if they didn't, we'd be in some trouble. Okay, let me finish my box and then let's go peek at another one.
I like the retest better. It's a lot easier.
You guys go, I'll catch up. Root almost sounds good, but the factorial, do we really want to have to worry about n factorial to the 1 over n? No. So if you haven't chosen yet, go ratio. Anything with a factorial. Almost, I would say n with a factorial, go ratio test.
Sure enough.
What? Good team. It's a nice one, right? Isn't this one going fast? No. But less writing than some of the other ones. Or less work, I should say. I'm about to, make this English. I'm about to figure out that ASB wasn't doing anything for high school Valentine's Day. That could have been a good deal for me.
Yeah,
Like
it's just-
roses from the LA Flower Mart.
It's just too expensive. The roses are really expensive. So we were thinking, I mean, we have to do crush grams.
We're selling cookies.
Huh?
We're selling cookies.
Yeah, see what you're doing. Protein.
But you said you wanted to do something with cotton candy. I said, you would probably talk to me.
Do you guys sell stuff in the ASP room? Just walk by there. I'm like,
Yeah, soon the Richmond says nice to say this.
so you guys do top water?
I got some.
Not many people do.
It was donated from
Sorry,
Richmond. It was not.
I didn't know if she was hot water.
And when it gets hot, you can do like popsicle ice cream sandwiches that she always
No.
but it's just not the right time right now. The bracelet thing, because she was excited, it's way too expensive.
Yeah.
We won't make any money.
And then the car wash.
I think that one could be a big one. I've talked to some more about that.
Yeah, we gotta do it soon because Karen, she wanted to do it.
Yeah.
And we can have you with the signs, everybody thinks that, like, oh, Steve.
Can you see in there?
With the little sign, with the,
Come
gotta
eat
help
car wash.
We gotta help her. I have a little person
Pretend
inside.
to be like falling on the floor. On the floor. I'm like, help me. Go to the car wash.
Can you help me go to the car wash, please? Like, I wanna let you hear it's only $10. I have a little British accent like Tiny Tim.
Wait, how do we do this?
With witchery.
Yeah, the n+1
Okay, yeah, that's
n
true.
factorial is gonna come out and cancels out.
Is it truly?
Yeah, it really
Are you
is.
sure?
Okay.
George!
Misty, you never know. Did anything cancel out?
You can make it n+1 to the n times n+1 and then n+1 cancel.
And factorial already canceled out, so don't worry about it.
Yeah, get out of here, factorial, you smell.
But where do we go from here?
So it's end to the end if you.
Yeah. n+1
Wait,
again.
can you do
You
that?
can go, no way.
Can you distribute it?
Oh, there you go. That's the next one.
And,
So now what? It's 1.
One.
We gotta learn our special converging sequences a little better.
and
Good thing the test isn't
I
over.
think the bottom wins 0. Bottom wins.
What?
I think so.
That is E.
Oh.
Turn
What?
up! Turn up, Misty! Math magic, I told you she knew math magic. It's witchery.
Look at that stinker! He was hiding in there! We gotta be aware of our logic. Usually it's good because we've trained it, but we haven't trained it in all things. Remember, we always have to hold to the truth. Can't just go off of what our brain says is true.
Why not?
When did this become
Life
semester 1 Bible?
I want to be able to do whatever.
Mathematical principles relate to
Or does life relate to mathematics?
I
What
just-
came first, the chicken?
life. So what can we say?
Series divergence.
Probably.
You say it in such a happy way, I'm just like, it's not happy.
I get to show Algebra 1 kids Fibonacci today. That's kind of fun.
I can't remember.
I never
Fibonacci.
learned Fibonacci.
Neither did I, besides Robert.
I didn't learn a lot of things.
Who is she? I learned him, and I
Actually,
can't
we learned it
remember
at
it,
camp.
but like, I can't remember it.
We remembered it at camp.
Yeah, from Ojai.
Oh hi, yeah.
That's where I learned
The,
it. With the bunnies.
tie-dye.
With the bunnies.
Wait, camp isn't.
There was
this is
one
math
bunny,
kid, is it?
and then one
No,
bunny,
like
two
school
bunnies.
camp,
They had
like
another
Ojai.
bunny, so I made 3 bunnies, and they had 2 more, but something like that. And it was like 1, 2, 3, 5, 20 million. That one. It's like,
That?
I think that's Fibonacci, right?
Yep.
Oh.
Now we know.
No. Robert Lyle was the one who explained it
It
to
doesn't
me.
start
That's like-
Because you have one bunny who can't produce yet in the first month because he's not old enough. Second month, you still have a bunny, and then he decides to go ahead and have a bunny so that in the third month, you have 2 bunnies. And then in the 4th month,
Got
this one
3.
decides to go ahead and
You
have
add
a
the-
bunny, and then
you
this
add the
one
2
goes
before.
ahead and has a bunny.
4 bunnies.
So it's like a family tree or something.
Yeah, it's like those Cheerios, the cell dividing and all that, but like with bunnies, and the bunnies are cooler, and they jump numbers.
Oh wait, no. This one's too
They
young to have a
bunnies
bunny.
together, don't they?
That one's too young to have a bunny. Remember?
Oh yeah.
Because that's still his first month. His first month, and he's there, and then he's there, and then the 5th month. Let's see. He's too young to have a bunny. He of course can keep on having bunnies, and he's still there. And then this guy can have a bunny.
And he's a bunny.
Ta-da!
So 2,
So then you
4,
have
5.
1, 2, 3,
5.
5. And what's the pattern if we were to keep going?
8.
8,
12, 13.
13.
It's the recursive formula that a sub n is equal to a sub
And
n minus 1 plus a sub n minus 2. And they're expecting Algebra 1 kids to write this formula. I say, yeah, no. I'll show it to them. And then that is when a sub 1 is equal to 1 and a sub 2 is equal to 1.
My question is
Bunnies.
this. Where is that useful?
Everyone.
And doing
Everywhere.
that, and find how many
Literally
bunnies you have. But
And it's like
and in
used
this
in
one, it's like
nature.
you have a rectangle and you cut it in half, and you cut it in half.
Because
and
that
you cut it in
exact
half,
same-
cut it in half, it'll never.
That exact same idea. A 1 by 1 and a 1 by 1 combined to make a 2 by 2 combined to make a 3 by 3. Oops. 2 by 2, combine to make a 3 by 3, combine to make a 4 by 4, combine to make a 5 by 5, combine to make an 8 by 8. Anyway, it keeps on going.
You lost me.
Going.
And then
Back,
when you
back.
spiral,
Cali.
What's that spiral mean?
it's found in a nautilus shell, it's found in a snail shell, it's found in
And you can never run out of
conch, like
tabs.
the inside.
There's
That's-
like different flowers.
It's found in the spiraling, found in pineapples and pine cones and sunflowers and almost any flower that has some sort of seeded pattern like daisies. It's found in cauliflower and like Brussels sprouts where they bloom on a branch. It's found in the the growing of leaves, like how spread apart they are.
Okay, did Fibonacci just make it up, or he just like noticed it?
Discovered it. Yeah, in a sense, discovered it. He was the one that came up with the bunny problem, and then he realized it was mimicked in nature. I think is how it goes.
That is so beautiful. How can
I know.
Now you know how to delete this page because it has nothing to do with BC.
No, it does. It does.
I know.
Because
Guys, our
the
whole
limit,
It's a sequence!
the
Alright, we're
limit
done.
is infinity.
So, moving on.
Yeah, the limit is infinity, he's right.
How about this guy?
Yeah, he's right.
Hey, he might be from
Said it
Porky something.
Wrong. Maybe I would have.
What do we do?
You did 96 on the board?
No.
Oh,
I said I enjoy those. It's a homework problem.
Oh, this is cool.
9. Oh, that is so cool. I got to the middle. And this is awesome.
Go team. It's the little things, it really is.
Ever since like pre-cal, I have like written the date on which I got to the middle of my topic.
Oh, that's fun.
Waiting for this day.
Could we maybe try ratio? Sure. Could we maybe try root? Sure. What are you guys trying? Pick one.
I do nth term. I'm gonna lie.
There is an nth term. What? You can pick ratio or root.
But we have to pick ratio or root.
Yeah. That's my advice. I mean, integral test definitely not. Limit comparison.
Never comparison,
Not feeling it.
no.
Because you can compare to two to the end, but that diverges, and the limit will be 0, so that doesn't really help. You can compare to
alternating series.
1 over n squared. Then you have 2 to the n, and that is infinity, and with a convergent, that shows nothing. Other comparison will be hard. Direct comparison will be way harder. Integral test is impossible. Nth term.
GN venture.
Nth term, you can just lapodal it. Yeah, I'm sorry.
Will work?
Yeah,
Tell me if it works, and then I'll try it out.
It does work.
it does work. So can I?
But
can I
we
get
might as well get the practice in.
But let's go ahead and see, because what if these two were flipped? And technically, I think it's in the ratio root section. So yes, you could do nth term, and that was probably my point of this problem was, hey, why didn't you check nth term? Because they were all trying ratio and root. But how could ratio or root show the same conclusion of nth term?
And that's what we're doing now.
That is what you're doing now. Do you guys know how to take the limit to infinity of 4n squared minus 1 to the 1 over n?
What?
Is anyone doing the root test?
I'm doing
Yeah.
ratio.
Do you know how to take the limit of the 1 over nth power of the denominator?
No.
Exactly. Stop. Do ratio. But good idea. If it was n by itself, we could do that. If it was n plus 1 over n or 1 plus 1 over n to the 1 over nth, we could do that. Other
Okay,
things.
stop.
Other things, yeah. That was a good idea.
That's a good idea.
Because you saw the nth root. Or sorry, you saw the nth power and that was good. But remember, ratio test works too.
What is ratio gonna work?
That's what I'm finding out right now.
You put it this way, ratio test can be used for nth powers as well. How about that? Now we're getting good practice of setting up the ratio test.
Are you guys expanding n plus 1 squared?
Or a better word, you know whatever she owns the way. Equals 2, okay.
No.
Equals 2?
What happened? No, it equals 1.
Half.
What? How does it equal 2?
8/4.
Yeah.
Oh, distribute the 2. Yeah, I see. Stupid George.
Oh.
7.
Yeah. Okay.
Or, as Gerardo did say, by the end term of the divergence test, what could we have said also?
Consider it as.
And goes with the fitting with
The top
the
wins.
series divergence.
Both work. And of course, the end term would probably be like the preferred one, but getting you ready for the test on Wednesday, there are
Are
multiple
you gonna
ways.
tell us where you have to do this one?
I'm basically going to give you a big old long list of them. I'm going to say, hey, you have to show me using each of the tests. Go.
Wait, is
So
it
you're
that?
gonna have ones that are easier to use.
Yeah. But you might want to go through and find ones that match up to the harder first. If that makes sense. Because you don't want to like do all the easy ones and then be like, oh crud, which of these can I actually do ratio with? Or comparison or direct comparison. So you're going to have to demonstrate abilities with each of the tests. So you might have one that could be shown with end term tests. Be like, oh stink, I still need to do a ratio test. I'll do that instead.
So would it be wise to start with direct comparison, limit comparison, ratio root, and then go to the easier ones?
Yeah, unless, well, I would probably do direct and then integral test. I would do direct and then integral and then keep going from there. Because you don't want to get stuck with one that you can't integrate.
True.
What would you guys do for the last one?
Oh,
Wait.
oops. Oh,
Do it an easier way, or do you want it root ratio?
Well, it technically is alternating.
yeah, I would do alternating series, so that's what it's
But then if you
for.
look at it, isn't the limit equal to 0 and the n plus first term going to be smaller than the n term? Is that true? Square root of n plus 1 over n plus 2. The bottom increases by a whole 1, whereas the top increases by like a square root of 1.
This is where I use a calculator and find out when it's a greater.
1 over 2 versus root 2 over 3. No, root 2 over 3 should be smaller, right? Than 1/2? I'm pretty sure as well. Because you would need 1.5 over 3 to be 1/2, and root 2 is going to be less than 1.5. Okay, so yeah, the series is decreasing. So we have conditionally convergent just by checking alternating, so that's not what we're checking. What are we checking for? Absolute convergence, and that's when we need to look at the absolute value, which means we're considering, right, the square root of n over n plus 1. Okay, what do you guys want to do?
Alternating series test.
We already did that. Conditionally convergent. Sorry, I did that in my head for sake of time. It's conditionally convergent, so now we have to test the absolute value. So what test do you want to use for the absolute value?
Ratio. Is it between ratio and root? Right?
Probably. Because square root of n over n plus 1. Not so sure you want to do integral test. That sounds yucky. Definitely not geo, definitely not p series. Limit comparison.
A limit comparison would be easy because if you just flip it over upside down, the limit it diverges. So
limit comparison to what, 1 over root n?
N plus 1 over root n, and that diverges by the nth term. And the limit is it equals 1. And then you can just go, you can just say limit comparison.
I'm gonna go with 1 over square root n.
That's what I was thinking too, just for sake of, but I'm not saying that one wouldn't work.
It's
The nth term test would work.
It's a little bit of a cheater way, but it only works if the inverse is actually you can tell whether or not it diverges.
Right, and not when you could because of the
Mm-hmm.
nth term test.
I'll do it, you guys. Oh, here's the. I just remembered. I was having some trouble with like direct comparison.
Oh.
What happens when the limit equals 1?
It diverges or
We
converges.
don't know. Oh, it just.
I know,
No,
careful,
L is-
right? It's
L
a
is
struggle.
one greater than
We have to
zero.
keep ratio root separate from limit comparison.
Converge.
Diverges,
Oh.
right? 1 over root n diverges.
Yeah,
Oh, yeah.
Alright.
Oh, there's still people in here.
You're okay, come on in.
Hi, guys. Oh, what class is that? Trigonometry.
Calculus.
Calculus.
How's it going, Jay?
Alright.
Bye, Joyce.
Be nice to you, Steve.
It should be